Oumuamua, which is an object that we detected in space that you believe could possibly have been extraterrestrial.
Oumuamua, the enigmatic interstellar object that captivated attention in late 2017 with its strange orbits, is once again grabbing headlines. This time, however, scientists are terrified. In a mere 2 weeks, Oumuamua is set to collide directly with Earth, an event that has never before been witnessed. What makes this cosmic occurrence particularly terrifying is not just the impending collision itself, but the alarming fact that Oumuamua shows no signs of decelerating. Are we facing a potential disaster?
At which point I started thinking maybe it's not a comet and not an asteroid, something else.
Join us as we delve into scientists' urgent warning about Oumuamua's direct impact to our planet, unveiling the mysteries of alien probes. When you hear the term alien probes, what comes to mind? Perhaps it creates images from old sci-fi movies where extraterrestrial beings use strange instruments to examine humans. Or maybe you think of something like Oumuamua, a mysterious, cigar-shaped object that zipped past our solar system a few years back. In 2017, scientists like Avi Loeb from Harvard University started talking about a different kind of probe. Not the fictional kind, but the real possibility of space probes sent from distant civilizations. These probes would be like the ones we humans have sent out into space, such as Voyager and New Horizons. But the big question is, could Oumuamua be a similar probe, just from a different planet? Avi Loeb, an expert in plasma physics, has even suggested that Oumuamua itself might have been an alien spacecraft. While that idea might sound far-fetched, it's got scientists buzzing with excitement. However, there are huge challenges. First off, the distances in space are mind-boggling. If aliens from the Andromeda Galaxy wanted to send a probe to Earth, it would have to travel an incredible 2.5 million light-years. That's 6 trillion miles per light-year. And then, there's the question of time. How do they make sure their probe gets here before their civilization collapses? But let's say they solve those problems. They'd still have to build a probe tough enough to withstand the harsh conditions of space, radiation, space debris, you name it. Think of it like building something super strong and tough, like a material that's as hard as a diamond but can also take a hit without breaking. Despite the challenges, the arrival of Oumuamua in 2017 got scientists buzzing with excitement. For decades, they'd been waiting for an interstellar visitor just like it. And who knows, maybe one day we'll discover that we're not alone in the universe after all. Back in 2017, Thomas Zurbuchen, who was NASA's Science Associate Administrator at the time, announced an innovative discovery: the confirmation of interstellar objects like Oumuamua. This revelation sparked immense interest among astronomers worldwide. Then, just 2 years later, in August 2019, another interstellar object, 2I Borisov, was spotted. Unlike Oumuamua, Borisov had the typical features of a comet, sporting a distinct tail and coma. This mysterious visitor offered astronomers a rare glimpse into other planetary systems beyond our own. Initially appearing 10 times longer than it was wide, resembling a colossal cylinder, later observations revealed it to have a flatter, pancake-like shape. Similar shapes have been observed in other objects in the Kuiper Belt, suggesting a commonality in their formation. By studying Oumuamua's brightness as it moved through space, astronomers deduced its dimensions and shape. Interestingly, Oumuamua's journey is traced back to a possible close encounter with 4 stars, with the red dwarf star HIP 3757 being its closest pass. This revelation left astronomers wondering about Oumuamua's origin. Did it originate from there, or has it been drifting through space for millions of years, its origins shrouded in mystery? The solar system is like a bustling neighborhood, with planets, asteroids, and comets all orbiting around the sun in tight loops. But in 2017, something extraordinary happened. An unusual traveler entered our cosmic neighborhood, named Oumuamua. Unlike the rest, its path wasn't a neat circle. Instead, it was hyperbolic, meaning it zoomed by the sun at a blazing speed, barely affected by its gravity. It was like a cosmic bullet whizzing through space. Oumuamua's presence was first noticed on October 19, 2017, by astronomer Rob Warwick from the University of Hawaii. At that time, it was already 21 million miles away from Earth, and it got as close as 15 million miles before continuing its journey away from our solar system. This interstellar visitor was moving incredibly fast, reaching speeds of 54.2 kilometers per second after getting a boost from the sun's gravity. But catching a glimpse of Oumuamua was no easy task. It was tiny and moved rapidly, giving us only a few weeks to study it up close. Luckily, the Hubble Space Telescope and other powerful observatories managed to capture some stunning images, revealing Oumuamua as a mere speck against the vastness of space. As Oumuamua speeds away, heading towards the constellation Pegasus, it fades from our view, disappearing into the depths of the Kuiper Belt, a region beyond Neptune filled with icy objects. But could it return? And what exactly was Oumuamua? Some speculate it might be an alien probe, while others think it's just a dead comet stripped of its gases over billions of years. One thing's for sure, Oumuamua's fleeting visit has left astronomers and space enthusiasts alike captivated, sparking debates and fueling our curiosity about the mysteries of the cosmos. However, Oumuamua's journey was not entirely straightforward. The Hubble Space Telescope noticed something peculiar as it moved away from the sun: a non-gravitational acceleration. Typically, comets emit water vapor and dust, creating a tail that gives them an extra push. But Oumuamua didn't exhibit any signs of releasing water or other volatile substances commonly seen in comets. So, what could Oumuamua be? Unlocking the mysteries of Oumuamua, one popular theory suggests it's a chunk of nitrogen ice. According to researchers Alan Jackson and Stephen Desch from Arizona State University, Oumuamua might be a fragment blown off a Pluto-like object by a massive impact. If the nitrogen ice had melted due to the sun's heat, it would have provided the extra boost needed. However, Oumuamua would have to be smaller than initially thought to appear as pale as it did. Another theory proposes that cosmic rays interacting with surface ice in interstellar space freed hydrogen gas trapped in water molecules, creating a supply of hydrogen gas trapped in amorphous water, ice. This theory, proposed by Daryl Seligman from Cornell University and Jennifer Bergner from Berkeley University, suggests that Oumuamua was warmed by the sun, allowing hydrogen to escape and altering the crystal structure of the ice, which seemingly propelled it forward. Additionally, astronomers Avi Loeb and Shmuel Bialy from Harvard University have suggested a rather interesting idea. Oumuamua could be a solar-powered spacecraft. According to them, the various peculiarities observed in this interstellar visitor could be satisfactorily explained by an artificial origin, hinting at the possibility of extraterrestrial technology at play. The path taken by Oumuamua suggests it originated from outside our local solar system. However, its true size and shape remain covered in mystery, since we couldn't capture a detailed photograph of this visitor. Astronomers rely on its brightness and their knowledge of how asteroids and comets reflect light to estimate its size. Since no coma or tail has been observed around Oumuamua, some scientists doubt the comet theory. Outgassing, a typical feature of comets, would also change Oumuamua's rotation period, which hasn't been observed. These scientists also suggest that Oumuamua's apparent movement could be from the force that broke it free from its parent object, but repeated non-gravitational acceleration contradicts this. Instead, there's the fascinating theory involving sunlight. If Oumuamua is extremely thin, around 0.3 to 0.9 millimeters thick, its observed movement could be due to solar radiation pressure. They speculate that Oumuamua could be a light sail, a technology demonstrated in space missions like the Japanese Icaros probe and NASA's nanosail D2. These light sails use photons' kinetic energy to propel themselves through space. The calculations suggest that a light sail Oumuamua could endure a long journey through interstellar space. They estimate it could travel at least 16,000 light-years from its home system, wherever that may be. The idea that Oumuamua might be an alien spacecraft or space debris is taken seriously. It could have accidentally landed on Earth, or it might be a purposefully sent spacecraft examining our solar system. The unusual way Oumuamua was discovered adds weight to these possibilities. If it's part of a random population of objects, stumbling upon it as we did implies that every star in the Milky Way ejects an enormous number of such objects throughout its lifetime. However, our solar system doesn't produce as many Oumuamua-like objects. Additionally, Oumuamua's motion closely aligns with a region of the Milky Way galaxy called the local standard of rest, making it challenging to determine its origin. Conventional rockets won't catch up to Oumuamua as it heads towards the outer solar system. However, sending small robotic probes with sails hurtling towards it at high speeds could be feasible in the future, with projects like Breakthrough Starshot aiming for this. Whether we reach Oumuamua or not, studying its visit can prepare us for future encounters. By conducting thorough observations and learning from this experience, astronomers can better examine other intriguing objects currently in view. If the Oumuamua space probe were to return, it would prompt further considerations and preparations. Should we consider building a Corallian shipyard if we entertain the idea of something extraordinary happening? It's worth pondering what steps we should take if the asteroid space probe returns. To construct spacecraft capable of pursuing it, humanity needs a deeper understanding of dark energy in the cosmos. One suggestion is to send a craft after the asteroid probe, but the challenge is immense. Oumuamua is traveling at a hyperbolic excess velocity of 5.5 AU per year, putting it beyond Saturn's orbit within 2 years. This speed surpasses anything humanity has launched into space before. So, what kind of vessel would we need? And what propulsion method should we use? Solar sails, or perhaps something more exotic like a wormhole? However, the concept of wormholes poses significant challenges, including collapse, links to other universes, and the lack of construction knowledge. Cosmic gateways and interstellar travel. Back in 1935, Albert Einstein and Nathan Rosen introduced a fascinating concept of wormholes within the framework of general relativity. They proposed the existence of what they called Einstein-Rosen bridges, or wormholes, theoretical passages connecting different points in space-time. These wormholes could potentially create shortcuts, reducing travel distance and time across the universe. Although Einstein's equations suggested the possibility of wormholes, none have been observed or confirmed to date. Some equations even hint at the presence of wormholes associated with black holes, but verifying this is challenging. Objects and beings entering black holes face an uncertain fate, making it impossible to determine if they connect to wormholes. At the heart of this concept lies Einstein's theory of space-time, which he envisioned as a fabric encompassing the entire universe. According to Einstein, the interaction of mass and energy warps this fabric, creating valleys that influence the motion of celestial bodies like planets and stars. This manipulation of space-time forms the basis for gravitational effects, rather than a direct force of gravity. Einstein speculated that space-time could be manipulated further, even torn, giving rise to the idea of wormholes. The notion suggests that if a hole were opened in space-time, there must be something on the other side. Surprisingly, Einstein and other scientists have proposed the existence of various types of wormholes, categorized based on their properties. Traversable wormholes are the most well-known and often depicted in science fiction. They serve as passageways between different points in the universe, enabling travel from one location to another, much like the wormhole in Star Trek Deep Space Nine. Non-traversable wormholes are inaccessible to travel. They may collapse before anything can pass through, or they lack an exit point, trapping anything that enters. The exploration of wormholes remains a captivating subject, blending theoretical physics with imaginative possibilities. While still largely speculative, the concept continues to interest scientists and inspire creative works in literature and film. There's the concept of one-way wormholes, which suggests that you can journey through one end of the wormhole, but you need another wormhole to return. Interestingly, some of Einstein's equations suggest that wormholes might exist within black holes, although they're not passable. White holes, on the other hand, are like the opposite of black holes. They shoot out matter with tremendous force. Then, we have two-way wormholes. These wormholes allow travel back and forth, offering a convenient round-trip journey. Intra-universe wormholes are found within our universe and serve as pathways between different points within it. Inter-universe wormholes, on the other hand, connect our universe to another parallel universe. If you're a fan of DC Comics or Marvel, think of these as the crisis wormholes that lead to alternate realities. Now the burning question: where are these wormholes in our universe? Well, theoretically, they could exist within black holes, white holes, and other massive celestial bodies. However, at present, they remain largely theoretical. This uncertainty is not uncommon in the world of science. Just because something is theoretically possible doesn't mean it's guaranteed to exist. It's akin to the mysteries of dark matter and dark energy, concepts that are supported by mathematical theories but have yet to be conclusively proven. Speaking of theories, Einstein's theory of general relativity provides a solid mathematical foundation for the existence of wormholes. However, it's crucial to remember that theories, no matter how well supported, are still subject to interpretation and further investigation. So, while we may dream and speculate about wormholes, their elusive nature reminds us that there's still much to uncover and understand about the vast cosmos. Perhaps one day, under the right circumstances, we'll finally unravel the mystery of these cosmic shortcuts. Until then, the quest for knowledge continues. Imagine a whole new possibility emerging as to why we haven't yet discovered wormholes. According to Einstein's theory, these cosmic shortcuts are like cracks in the fabric of space-time. However, it's conceivable that nothing in the universe has managed to breach this fabric. It's not that it's impossible, it simply hasn't happened yet. Interestingly, some science fiction shows and movies depict spacecraft creating their own wormholes by tearing through space-time. So perhaps the reason we haven't found a natural wormhole is because we need to create one ourselves. Alternatively, these wormholes might already exist in space. We just haven't stumbled upon them yet. But how could we miss a wormhole in space, you might wonder? Well, consider the sheer enormity of space. It spans trillions of light years. Despite our efforts to explore it, we can only observe a small fraction with any regularity. We can spot stars and planets in distant galaxies, yet we're still discovering new moons in our own solar system. With our limited ability to survey the cosmos, it's understandable that some phenomena evade detection. So why not wormholes? The most plausible explanation is rooted in the Big Bang theory, which suggests that the universe began with a colossal explosion, scattering matter in all directions. Over millions and billions of years, this matter merged to form the universe we know today. However, this stormy event likely created numerous holes in space-time. Some speculate that these holes are interconnected by cosmic strings, forming a network of wormholes waiting to be uncovered. Now, let's consider the cosmic scale of things, unlocking the secrets of wormholes. If there were just 5 wormholes in the entire universe, ones with both entry and exit points, randomly distributed, what are the chances of one ending up near us? Would we even recognize it? Could we detect it amidst the vast expanse of space? These questions underscore the challenge of finding wormholes and highlight the mysterious nature of our universe. Consider Star Trek for a moment. In the show, wormholes were only visible when someone approached them. Finding a stable wormhole was rare, like in Star Trek, The Next Generation, where one collapsed after a ship entered it, leaving the crew stranded far away. That's what made the wormhole near Deep Space Nine so unique. So maybe the reason we haven't found a wormhole yet is simply because we haven't stumbled upon it yet. Oh, and here's an interesting thought. Some people believe that the centers of galaxies might be wormholes instead of black holes. If true, it could mean that all galaxies are connected by the cosmic strings I mentioned earlier, which would be quite remarkable. Now, let's ponder another question. If a wormhole existed, could it just exist without any interference? Well, let's think about gravity for a moment. Wormholes, as we imagine them, are openings in space that connect different areas, but gravity is a force in the universe that would likely oppose such a thing. So if a wormhole were real, the universe might try to close it up due to the natural pull of gravity. Look at black holes, for instance. Some can resist this force and survive, while others collapse due to factors like Hawking radiation. This suggests that if wormholes were created during the Big Bang, they may have closed up over time due to the forces at play in the universe. However, the cosmic strings we mentioned earlier could be a reason why some wormholes persist. These strings might provide the energy or matter needed to keep them open, although this is still just a theory. Even the powerful warp engines of Star Trek had their limits. That's why a stable wormhole was something everyone desired and coveted control over. Imagine having the entire universe within your reach, even if only from a scientific standpoint. It's incredibly enticing, especially when it comes to studying distant galaxies we may never physically reach. But let's bring it closer to home now. If we could create our own wormholes, we could embark on the first human journey across the stars. This is a goal humanity is currently striving towards with missions to Mars. But picture this: launching into space, generating a wormhole just beyond Earth's gravity, and instantly arriving on Mars. Think about how this would expedite the colonization process and save countless resources in making Mars habitable. And if we could do it for Mars, we could do it for other places too, like Saturn's moon Titan or even Alpha Centauri, often seen as a potential new home for humanity. A wormhole is like a cheat code for space travel. Instead of building ships capable of reaching distant places within specific timeframes, we'd just need vessels sturdy enough to endure the journey through the wormhole. It's a captivating vision, but for now, it remains just that, a dream. Yet, it's a dream that ignites excitement and curiosity among both science fiction enthusiasts and scientists alike. Because understanding and harnessing the power of wormholes is quite complex, there's an intriguing suggestion: creating a launch pad on the outskirts of the asteroid belt. This idea echoes Freeman Dyson's proposal known as the ALO drive. This ALO drive would simulate riding a moving conveyor belt through an airport. Another concept is the warp bubble, where space-time curves around the ship, creating the illusion of propulsion. However, constructing a warp engine faces numerous hurdles, including the need for negative mass, which remains a mystery in the cosmos. The idea of propelling a spaceship as small as a car would require an object with the mass of Jupiter, which is quite mind-boggling. How humans could manage to utilize this incredible force remains a mystery, adding to the fascination surrounding the swift movements of Oumuamua and 2I Borisov. Insights from interstellar travelers. The Hubble Space Telescope snapped some pictures of 2I Borisov. These images helped scientists confirm what it was and how it differed from Oumuamua. Certainly, 2I Borisov, like Oumuamua, is special because it hails from beyond our solar system. But scientists are fascinated not just by its origin, but by what it can teach us about the wider universe. Even though other star systems may differ from ours, the fact that this comet's features resemble those of the materials that formed our solar system is quite remarkable, remarked Amaya Morrow Martin from the Space Telescope Science Institute. What adds to its allure is its swift movement. Traveling at an astonishing 110,000 miles per hour, Borisov is on a hyperbolic path around the Sun, meaning it won't stick around for long. Unlike most objects in our solar system, it won't be slowed down by the Sun's gravity. Going by its speed, scientists predicted that Borisov would whiz past Jupiter and then vanish into the depths of space, never to return. This sets a ticking clock for NASA and other space agencies as they race to unravel more about its composition and behavior before it bids farewell. New comets can be quite unpredictable, noted Max Muchler, another member of the observing team. They may suddenly brighten or even break apart when exposed to the Sun's intense heat for the first time. Hubble stands ready to monitor whatever unfolds next with its advanced sensitivity and resolution. Despite the time constraints, space teams worldwide are striving to secure more observation time to uncover more about 2I Borisov before its fleeting visit comes to an end. Although scientists are eager to gather more information about 2I Borisov in the coming months or years, we already have some clues about its nature. Indeed, we've identified it as a comet, a significant detail that helps characterize this interstellar traveler. One key indicator of its cometary nature is its coma. For those unfamiliar, the coma is the hazy cloud surrounding the comet as it travels through space. This fuzziness is caused when the comet's rocky core interacts with the heat of a nearby star, causing it to partially melt and release gas and dust. Determining the comet's size has been more challenging. As it journeys through space, estimates of its dimensions have fluctuated based on the observing technology used. However, current estimates suggest the nucleus of the comet ranges from about 1.4 to 6.6 kilometers in diameter, making it quite sizable. In essence, 2I Borisov behaves like a typical comet found in the universe, except it's hurtling through star systems and happened to pass close to our own. Oumuamua stood out for its unique characteristics. Unlike typical comets, it didn't have the expected tail and coma. Despite predictions about the existence of interstellar objects predating Oumuamua's discovery, its unusual appearance puzzled astronomers. Some thought that it might be outgassing, possibly from hydrogen or nitrogen ice sublimation originating from another solar system. Yet, there are scientists who argue that this could resemble the Voyagers and New Horizons probes, but this time originating from a different planet. 40 years ago, in August and September of 1977, a team of humans sent out 2 robots on an incredible journey to explore the vastness of space beyond our solar system. Leveraging a rare alignment of planets, the twin Voyager spacecraft embarked on their epic voyage. They first zoomed toward Jupiter, utilizing its immense gravity to catapult them onward to Saturn. At Saturn, their paths diverged. Voyager 1 veered upwards, venturing toward the unexplored realms of interstellar space. Meanwhile, Voyager 2 continued its journey, navigating a winding course through the outer planets, en route to Uranus and Neptune. With each encounter, the fuzzy specks in the distance transformed into vivid worlds, offering profound insights into the mysteries of the cosmos. Voyager captured amazing images of Jupiter's complex jet streams, revealing swirling patterns within patterns. It witnessed the otherworldly spectacle of Io's volcanic eruptions, a moon warped by gravitational forces, and Europa's enigmatic icy surface concealing a hidden ocean. 2 years later, the Voyagers reached Saturn, the jewel of our solar system. Its majestic rings, once seen as a seamless band, now revealed intricate grooves and moonlets patrolling its periphery. Voyager delved into the methane-laden atmosphere of Titan and observed the enigmatic Iapetus, alternating between light and dark sides like a celestial yin and yang. After bidding farewell to Saturn, Voyager 1 ventured towards the cosmic unknown, while Voyager 2 pressed onward. It encountered Uranus, a peculiar planet tilted on its side, presenting a mesmerizing blue-green hue and faint rings. Then, it journeyed past Neptune, a serene world marred by tumultuous hurricanes swirling in its atmosphere. Meanwhile, back on Earth, antennas strained to catch the faint signals from Voyager, now nearly 3 billion miles away. Voyager 2's final destination was Triton, Neptune's largest moon, adorned with dark nitrogen geysers amidst its icy landscape. With Triton, Voyager concluded its remarkable odyssey, adding one more celestial marvel to its illustrious tally. The Voyager mission was more than just observation. It was a cosmic messenger. Each spacecraft carried a unique message in the form of a gold record, complete with a needle and instructions for playback, like a time capsule from the 1970s, capturing the essence of Earth's sights and sounds. Etched into this golden disk were greetings from humanity, expressing our desire for peace and friendship as we ventured into the unknown depths of the universe. These recordings, alongside photographs, were destined to outlast our planet, floating as scratches on gold through the vast emptiness of space. As Voyager 1 bid farewell to our planetary neighborhood, it turned its cameras back towards home, capturing an iconic family portrait of our celestial siblings. Earth, a mere speck of light amidst the vastness, was famously described by Carl Sagan as a pale blue dot, a reminder of our humble place in the grand cosmic scheme. No other spacecraft has ventured as far or witnessed as many wonders. While the Voyagers may one day encounter another civilization in the distant future, it's possible that by then, humanity may no longer exist. Yet, these silent sentinels will continue their eternal voyage through the cosmos, carrying with them the echoes of our existence. Their silent journey serves as a poignant reminder that once we roamed among the stars, leaving behind a legacy of curiosity and exploration. In January 2006, NASA's New Horizons spacecraft embarked on an epic journey toward the distant world of Pluto. This incredible spacecraft marked the first human-made object to ever come close to the icy dwarf planet. But its ambitions didn't end there. It aimed to venture even further, delving into the mysterious Kuiper Belt, where an enigmatic object dubbed Ultima Thule awaited exploration. To reach the outer reaches of our solar system and fulfill its mission, New Horizons had to travel through a risky expanse known as the asteroid belt. This region, situated between the orbits of Mars and Jupiter, is not merely a desolate void. It's teeming with countless rocky bodies, like a celestial highway of sorts. Among these celestial wanderers, New Horizons encountered a small but significant asteroid named 13254APL in June 2006. Though it may appear as a mere blur from afar, this rocky traveler measures approximately 1.6 miles across. Zooming past at a distance of 63 miles, New Horizons seized the opportunity to test its instruments, despite some not being fully operational at the time. After navigating through the asteroid belt, New Horizons set its sights on the colossal gas giant, Jupiter. Arriving in 2007, the spacecraft captured breathtaking images of this majestic planet as it approached. During this encounter, Jupiter's immense gravitational pull acted as a cosmic slingshot, propelling New Horizons to even greater speeds and redirecting its trajectory towards Pluto. This gravity assist boosted the spacecraft's velocity by a staggering 8,700 miles per hour, shaving 3 years off its journey to the distant dwarf planet. What are your thoughts on scientists' warning about Oumuamua? Let us know your opinion in the comments below. Like, share, and subscribe for more space content.